Prove by mathematical induction that the sum from r to 1 of n of 1 over 2r minus 1, 2r plus 1 is equal to n over 2n plus 1. Okay, so it's very similar to the previous video, but just maybe a bit more difficult. So the proposition was from r to 1 of n of 1 over 2r plus 1 times 2r plus 1. And if you write out a few terms, that becomes 1 over 1 times 3, 1 over 3 times 5, 1 over 5 times 7, 1 over 2m minus 1 times 2n plus 1 will be equal to n over 2n plus 1. Right, so we prove true for a particular value, n is equal to 1. So on the left-hand side, we get 1 over 1 times 3, which is a third. On the right-hand side, we get 1 over 2 times 1 plus 1, which is also a third. Therefore, we can say true for n is equal to 1. Now what we do is we assume true for n is equal to k. So our proposition 1 over 1 times 3, 1 over 3 times 5, 1 over 5 times 7, plus 1 over 2k plus minus 1 times 2k plus 1 will be equal to k over 2k plus 1. So we now prove true for n is equal to k plus 1 by adding k plus 1 to both sides of this. So you need to be careful here because you're in k plus 1. Okay, and then we also need to do it to the other side as well. So this time I've written, instead of k here, I've written k plus 1. So we're going to expect this, all of this, to come out to be k plus 1 over 2k plus 3. And if we do that, we proved it. All right, so this becomes 2k plus 2 minus 1, which is 2k plus 1, and this becomes 2k plus 2 plus 1, which is 3. Going for a common denominator, we get k times 2k plus 3, plus 1 over 2k plus 1, 2k plus 3. Multiplying out, we get 2k squared plus 3k plus 1 over 2k plus 1, 2k plus 3. Writing that out again, what we need to do is factorize the numerator. So factorizing the numerator, it's 2k, k, 1, plus 1 and plus 1. If you're not sure, pause the video and practice factorizing for yourself. So you get 2k plus 1 times 2k plus 3. Obviously these will cancel out. And then we got the result that I mentioned, which is k plus 1 over 2k plus 3, which is the k plus 1 term. Okay, which you get by doing that. Therefore, the result is true for n is equal to k plus 1, and therefore the result is true for n is equal to 1, and if it's true for n is equal to k, it is also true for n is equal to k plus 1. Therefore, the result is true for all n belonging to positive integers by the principle of mathematical induction. Unfortunately, you do need to write down this conclusion. It is important. It is part of the proof. So what we're saying, if it's true for n is equal to 1, then it will be true for the next value, which is n is equal to 2. If it's true for 2, then it's true for the next value, which is n is equal to 3, and so on for all positive integers. Okay, so this has been a video to show you how to prove a series by the principle of mathematical induction. I hope you've understood, and I thank you very much for watching.